Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello and welcome into another episode of DevOps Accents, a podcast where we, the co-founders of MKDev, get together to discuss all things around DevOps, cloud-native technologies, artificial intelligence, data, and everything that gets into our attention and what we would like to discuss. And today we have a guest, a very dear friend of ours, Florian from KIWI. Florian is head of product and engineering at KIWI, a company that is a market leader for digital access management for housing industry in Germany and hopefully in other countries soon. Welcome, Florian. How are you?
Thank you for having me. I'm good.
Glad to have you here on our podcast. Hi, Pablo. Hi, Kirill. How are you guys?
Hey, Leo. What's up?
We are okay. Thank you, Leo.
Florian, you know our podcast called DevOps Accents. So naturally, my first questions to you would be, what is your accent?
Language-wise, German probably.
German, really?
German, yeah. Swabian, if I wanted to be more precise, is my, well, not really. Actually, everyone says it's barely there, but my language-wise, my accent would be German. If you want to know about interests, if that's what you're asking, or was it about language?
It was both ways.
I would say interest-wise, my accent or focus of interest is everything informatics, IT, building software products is kind of the big thing for me, but that's pretty much my job description. So I think that kind of comes from there. How to build software, how to build good software, how to build product, not just any software, how to build a product that works for the intended users. It's kind of what I'm mostly into right now.
What head of product and engineering at KIWI does, and how did you end up there? You started in a kind of separate industry, and then you appeared here. What was your journey in terms of DevOps? How did you?
Well, I studied computer science, informatics in German. So that is pretty much on the right track already for the job that I have right now. I then did my PhD in, officially it's in engineering, effectively it's in theoretical computer science. So really formal methods and mathematics and stuff like that. That went quite well, and I developed a tool for software-bounded model checking, which is a special method of code analysis as part of my PhD, and that turned out quite well. And there was some industry interest in this. So with some colleagues, I founded a company, startup, did that for a bit, then realized that it's way too early for this, for commercialization. It's too close to fundamental research and not nearly anything that you can really make money with yet. And then I left that startup, and that's when I stumbled into IoT. So my first employer after university was an IoT company, IoT Internet of Things, and from there, a few years later, it kind of brought me to KIWI. I think that was that company back then did a low power, long range network. I had a focus on this and built an IoT platform for this kind of networks. And that was really, really interesting. The company eventually shifted to asset tracking, which I wasn't terribly into. So at that point, I decided if they're shifting focus, I can do so as well. And that's how I ended up at my current employer, KIWI.
Do you think IoT, Internet of Things, was your choice, or you just end up there accidentally, and then it just happened that your career began growing into this industry, or was it your general interest to develop this part of the industry?
I would say I'm a person who's easily interested in different things in technology. So I tend to stumble into that kind of thing. No, it was not initially an interest of mine. When I studied, my first interests were computer science, were computer graphics, computer vision, and operating systems. Then I did my minor in medicine, which I then also left behind. Then I started theoretical computer science, did that for a while, and kind of, concluded this and then lost interest to some degree in the whole topic. And then I moved on. And then it was purely coincidence that I ended up in IoT. And I think now at this point, it feels like my experiences from my previous job helped me a lot in my current job. And that is kind of a very, very positive and reinforcing feedback, which feels good and keeps me in IoT because of all the stuff I learned I can apply now. But at the end of the day, it's just a coincidence, I would say. Sometimes I just let life carry me to certain places or in certain situations.
Because for me, I don't know how you guys, because for me, Internet of Things was something I'd say a gimmick for a very long period. I first heard about it like many years ago when a number of different devices started including Wi-Fi connection into it, and you had like refrigerator with internet, and it was like, why do you need that? Oh, because in the future your refrigerator will be able to scan the inners of your refrigerator and be able to predict your diet and order food for yourself, and you will be able to get it. And I was like, okay, it sounds promising. But and then more and more, while I was exploring the industry and the vacancies, the companies, and a lot of them was we are working in the area of Internet of Things, and I was wondering like, why? What do you even do there? And it took me quite some time to realize that almost anything that we currently use has internet built in it, and just not just cars with navigation and connection to internet and many more things. But I don't think that I have an experience with that besides other than having my smartphone connected to the internet constantly. But I don't think that it is Internet of Things because it's basically just a handheld laptop in my hand. So what is your experience with Internet of Things? What did you use?
For me, in my case, I remember in 2002, I was giving a talk about IP version 6. And the problem for the people in this talk, it was the same. What happened because the number of IPs is limited in version 4, and the people was scared that everyone is going to have many objects at home, not only the laptop, or no laptop at this time, it was more the desk computer. So everyone was afraid that what happened if, for example, I'm going to have a washing machine and everything, and then everything connected to internet, I need to have more IPs. Then the version 6 of IP was something like, okay, this is the solution for everything. And it was the moment when everything wanted to move to IPv6 because everyone was thinking exponentially. Okay, at home I'm going to have 200 objects. And really, if I check in, and I am not a guy like, for example, Kirill, that everything is connected to internet, even a plant, whatever thing is connected to internet. So if you check, your TV is connected to internet. You can have a watch connected to internet. You can have a fridge these days that it could be connected to internet. Mm-hmm. And there are many solutions. And for example, a doorbell, a way to open the door, like in KIWI, that is connected to internet. So you can have thousands of things connected to internet. But it's true that what happened in the 90s and 2000, this idea of why should I connect a washing machine to internet? It's like, for example, the bicycle that you bought the other day, Kirill, is connected to internet. And it's crazy.
I have a small confession to make. You might think because I work in Internet of Things that I must love technical gadgets and stuff like this. Not really, actually. I'm rarely one of the early adopters, so it took me quite a while to buy my first smartphone, and I had it for a while. And when that one broke down, I didn't replace it for a few years because I didn't need it or didn't want it. And even now, I'm super reluctant about getting more technology in my home. So I'm not too much into that actually. So you might say, why the hell is he working at KIWI then? He's digitalizing doors. Isn't that smart home? Isn't that exactly what he's not really that much into? It's not exactly. What we're doing at KIWI is that we're kind of stopping at the apartment door. So we digitize the apartment door so you can get into your apartment, but we're staying pretty much outside. What we're focusing on is the housing industry. What we're doing is is multifamily homes, the main entrance door, basement doors, parking garage, all of those different doors that people need to have access to for maintenance, for cleaning, and so on. And we also digitize the apartment door, but that's where it stops. We're not actually getting into the apartment. So I would say KIWI is that is as close as I'm letting the smart home things into my home, actually. And this I really like. It's pretty cool, actually. But I don't need all of that stuff in my living room, really. And yeah, so weird thing, but I'm not the only one who's like this because I remember that some years ago I talked or a colleague of mine and me visited Mercedes-Benz and we tried to make small talk about, and what's the obvious choice as a topic? That's cars. And we tried to talk about cars. And the guy who worked at Mercedes said, well, I don't really know. I'm actually not that much into cars. And at that moment, I realized it's kind of okay to personally have a different preference about this kind of stuff and still love your job and, do a good job at that. And you don't have to, um, love the thing that you're doing out on the end. Well, for KIWI, I do because I think it would be super comfortable for me if my landlord had this installed here. That would be nice. But at the end of the day, at the apartment door, that's where I'm kind of stopping. That's the line for me.
So, besides apartment locks, what else can be considered Internet of Things? Because I can imagine, like, I have, for example, here I have a doorbell that includes video recorder that I can connect to the video cameras around the building and see who's coming. Is it Internet of Things or smart house?
You can take it quite literal. Everything that's on the internet is Internet of Things in a way. It's a super wide term.
So basically, smart TV on my TV is as an Internet of Things as well.
Kind of could be. I mean, I have a TV that could be smart, but it's not connected to the internet, so not part of the Internet of Things. I would even say that sometimes the Internet of Things, I mean, there's not the one definition. Sometimes the Internet of Things is the technologies that you have. Even if a company runs something on premises intentionally disconnected from the internet, I would still say the technologies that they're using are Internet of Things technologies or can be. So sometimes that term even leaks into bits that are not directly connected to the internet. But I would say, yeah, everything that's smart home, if it has smart in front of it, it usually is meant to be part of the Internet of Things. People consider themselves part of the Internet of Things ecosystem when they develop smart TVs and smart whatever.
Correct me if I'm wrong, like guys, and you maybe you have another examples, because from my point of view, anything that can be connected to internet somehow, as you say, is Internet of Things, and in the end of the day, everything from my smartphone, my PC, laptop, TV, whatever is they can be connected to internet, but in the end of the day, they are just smaller version of a personal computer. They just put it in a smaller box, just as you can have a very tiny, small smartphone, and essentially this is a personal computer.
You could say it's a peripheral, right? It's at the end of the day, there's still a person sitting in front of it or using it. That's a valid distinction. It's the Internet of Things if the thing operates on its own and doesn't require or usually have a human being sitting in front of a screen doing something.
Yes, and I just realized, like, I know another example of this kind of thing is not so long ago, Apple announced, and all other companies, they have this like a keychain that helps you to locate your missing things. You just put it in there, or you're connected to your key or to your phone or to your bag, and you can track where your thing is on the map. But you do not have any human to PC interface to operate it. You just drop it, you just make sure it is charged and it works on its own. Like, is that the best example of Internet of Things you're working with? And if yes, like, what I think like it's much more complex device than a small personal computer, because you somehow need to make it operating without a screen, without buttons, without anything, and it still works.
I think the problem with the Internet of Things as a term is that it's extremely broad and very, very unspecific. So there's a lot of areas of Internet of Things that's more interesting. So for example, in our day-to-day work, we rarely use the term Internet of Things to talk about what we're doing, because that's just not an interesting word or a useful word for us to use to make distinctions and to, help clarify things. Yeah, if I talk to someone outside, this is one of the sentences I like to use, and people have like an image in mind then that it's devices that are connected to the internet and do something. But at the end of the day, it's way less of an important word when we actually work in this. There's smart home. This is when you let the devices into your living room, when you have like smart light bulbs, smart TVs, all the things that you know from at home that you might be buying and saying, oh, this is the Internet of Things. But there's also the industrial Internet of Things, where manufacturing machines are equipped with additional sensors that measure vibrations, power consumption, and so on. So this is also Internet of Things if it's connected to the internet, and then you can, discuss if it's still Internet of Things if it's not connected. But it's all about the connectivity of devices for all different purposes. There's smart city, which is also a huge area of the Internet of Things, where cities and municipal service providers monitor, for example, things like traffic lights, street lights, if there's water levels for rivers, for basins, for anything. Whatever their problem is, you can buy some sensors to measure stuff, hook it up to the internet, get the data, and start analyzing data. It's one of the most basic use cases, but it could also be something like e-scooters, for rental e-scooters. They're also connected to the internet usually. That's how you unlock them and how you interact with them. So it's an incredibly broad term that encompasses a huge amount of different kinds of devices, network technologies, use cases, industries, and different business domains that all use this in a completely different way. And if you randomly pick two people who work in Internet of Things, there's a good chance that they will completely miscommunicate to each other, because they work in so different areas that they're just not going to understand what the other person really is doing, or misunderstand certain things. It's big. It's just big.
One of my earlier impressions, or one of this, during this hype wave when Internet of Things was all over the news before crypto and AI, AWS also released lots of IoT stuff, and I remember they have this IoT button. So basically, you order a physical button that can trigger a Lambda function in your cloud. So they send you the physical thing, and then
Is it the dash button where you can buy?
I just googled. I think now it's called just IoT button, but then dash button also is mentioned. And then many companies created their own versions of this button to just order stuff. So if you're out of toilet paper, there would be like you stick a button in your toilet, you press on it, and then it makes an Amazon order for the toilet paper.
But this is a really smart solution, the buttons. I really like that one because it's this on this edge of being low tech. Like let's say you have a coffee machine in your office. You could try to measure the filling level of the coffee, of the water, hook up with the machine, observe how much power consumption it has. Is it turned off properly? Does it run smoothly? Would it, you can measure the vibrations. You can do a lot of different things. Or you install one button, and if a user observes something, he just presses it, and someone comes along and does maintenance. And I like the button. It's simple. There's a lot of intelligence built into this, but the humans who push the button, why not? Why not go for the simple one instead of all the over-engineered complexity of, fully autonomous and
Why not to make a call? Because my question is, why do you need a button? Maybe you need to make a call. That's all.
You can make a call too, true. The button is kind of nice and convenient. It's like you press the button and you leave again. Someone is going to come. The call will at least tell people what exactly is happening. So maybe the call is really old school. Being old school might be just fine.
Yes, that's what I mean, because sometimes we try to make things that we don't need to have, like a button to press the button when something happened in a coffee machine.
For me, one of the biggest attractions of Internet of Things is this maintenance part. For example, I got a new dishwasher last year, which has like Internet of Things, and I don't really care that I can control it from the smartphone because on it you can just press the couple of buttons. But for me, the killer feature is that I get all the information when it needs maintenance. So it says like the Klarspüler in English, like in the word. Like if it's out of this liquid, it just gives you notification. If it's out of salt, it also gives notification. And then some companies go even further, like the robot vacuum cleaners. They can also track that, okay, the filter is out of capacity, or it's too old, then can automatically order for you new filters. So you don't need to guess, you don't need to track, just you automate the maintenance of your devices and you get all the data when it needs to be fixed or adjusted.
But vacuum robots, I do have a vacuum robot, and I also have one that swipes and not just vacuums, and I'm definitely going to buy a new one once that one is broken down. But I do like the fact that I have one of the old ones that don't have cameras that watch me and are not connected to the Wi-Fi, but they just autonomously, in random patterns, zigzag across the floor and clean. And that's all I need, really. It works for me, and I don't really dig too much the idea of having like an additional webcam that's connected to the Wi-Fi in driving around my living room. I don't want that. Maybe this attitude is a really good attitude to have if you build this kind of system like we do at KIWI, because it gives you a certain amount of caution about what you built in there. I don't want to build a system that I wouldn't want to use myself. So I think at the end of the day, having this kind of mindset is actually a good thing in my position, I believe.
Yeah, in case of logs, it's also like one of the, a big step. Okay, first of all, I have a story about German logs because it's one of the things that every immigrant who comes to Germany is often shocked that there is a super fancy lock or key that fits to every door so that it unlocks the door downstairs to your apartment and to the basement. And then the problem, if you lose this lock, then you have to pay like over 2K and replace locks for everyone, the keys for everyone.
Which would not happen to you if you had digital access. That's kind of the primary benefits, one of them, of KIWI. You might think, we all used to think about this kind of stuff as consumers. You think, how does it affect me as someone living in the apartment having this digital access management system? And well, it's convenient. You can be on vacation and give your neighbor access to your apartment to water the flowers, which is really nice. And I could have needed that 2 years ago. Really, really needed that. But at the end of the day, for the housing industry, the primary benefit is slightly different. They have a way easier time letting people into apartments and locking them out again. Tenants, service providers, cleaning personnel, maintenance, everything, without having to worry about exchanging the locks all the time. They install those locks once and that's pretty much it. And then the same lock stays on the same door until it breaks down, which takes quite a while. You have to exchange batteries, but that's a relatively simple operation because any battery is fine of the right model and the right type. While when you have to exchange the physical keys for those more complicated locking systems, it can get expensive quite quickly, and it requires a lot of knowledge about how all of that works and which lock is suitable for which door exactly, and who needs new keys now, because that's the next thing that happens. You exchange the lock at the main entrance door. What's going to happen with the keys now? And just reducing all of that complexity is a big driver for at least some of our customers to use the system. So we are B2B is at the end of the day.
Which I think is great because like there are also solutions like Nuki, for example, that should be B2C, but like it's basically hoping that millions of people will move to digital locks. Whereas like in your case with B2B, there are just whole buildings with digital locks. So there is not even an option for people. They're like forced into the next like version of locking solution.
We don't find what force anyone really. But yeah, eventually, if they're not getting offered a physical key, they are getting forced by the housing company into this. But we're really careful about making sure that we are actually also providing benefits to the tenants at the end of the day, and that they also get something out of this. So we're trying to make sure that they actually embrace the whole thing, and quite a few do. So they like being able to open doors hands-free. So you walk towards the building's main entrance door, and even before you get out your key, it already opens for you because you have your transponder in the pocket, and that sends the signal to the door to open. And that's the kind of convenience that really some people are into and say that's just awesome. I can carry my bags in my hands and don't have to let anything go. I just push the door open with my shoulder and I'm in.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.
But when it comes to things like these locks, right? That they're tiny. They are working from a battery that you need to replace once in a while. But how they operating from the inside? I assume you cannot have a chip or a storage there that can run Linux or something like that. That it will maintain connection, and then when a new tenant moves into apartment, you have to rewrite all the information about this tenant and to set his lock connected to the, his key connected to the lock. It has to be updated, and because how tiny it is, like how does it even work?
There's a lot of different products on the market about digital locks in general. So they all work slightly differently. Some are more suitable for consumer use. So they just hook up to your Wi-Fi network. And that's relatively simple.
So you have to have a Wi-Fi chip inside this device?
On those products, there's a Wi-Fi chip, and they connect to your home Wi-Fi. So you essentially tell it which Wi-Fi to go into by it gives you a Bluetooth connection or a Wi-Fi connection too, depends. You connect to the lock, you enter your Wi-Fi credentials, tell it thereby to connect to the Wi-Fi, and then it's online. Some are completely offline. Some are just you and your smartphone, one-to-one connection, and you can kind of over the internet send invitations to others to use it, but it's just a very, very localized thing. For us, it's different. We are not in the apartments. We cannot use the tenant's Wi-Fi. The only thing that is, and usually the housing industry and the bigger companies, well, even the smaller ones, usually the landlords don't have their own Wi-Fi in those buildings. So there is no connectivity yet when we get into those buildings. We started more than 10 years ago. Back then, definitely not. But even now, it's rare, really rare, that those housing companies have Wi-Fi or any other network technology in their buildings. So what we do is we bring our own. We have a gateway, which is a small device that you install somewhere close by the lock that connects to the internet via the mobile phone network. And then there's a connection between those two. And that's how we can reach the lock even through the internet. So you can send an open command through the internet to remote open the doors, which is really convenient. And that's also how the device is configured and operated. However, we are currently investigating an offline product because those gateways are nice and convenient, in the sense that all devices are online and you can reach out to them at any time you like, but they are also quite expensive to install. They need to be installed at a place where they can connect to the lock, but also to the internet, to the mobile phone networks, which limits your options where you put it physically quite a bit. You need power because while the lock itself is low power, that device requires mains power. So you are really limited in where you can install this kind of device. Sometimes you have to install antennas, have like somewhere else, and have a cable that connects the two of them, which increases installation time, price again. And then even in basements, we sometimes are really running out of options with this. There's just no place where you can put a gateway that would connect to the lock and also to the internet at the same time. So we are investigating currently an option that goes for offline use. So we use the smartphones of the users as software-defined gateways, you could say, where these are the short periods of time where through the smartphone we connect to the device. Can happen asynchronously, so you don't have to be online and at the lock at the same time. It requires some good handling of the crypto concepts behind this to make it secure. It's non-trivial to do, but we're in good faith that we're going to finish that project soon and can go public with this, with more information about that. But in general, that's the idea. So yeah, in that case, you do go to the lock and update it with your smartphone, but you don't need to sit there and configure it live. The information still comes from a central server.
And Florian, how is the people reacting to, the people above 40 years, because I have to imagine that, all these objects that are coming with the Internet of Things, and I'm not talking about people with 70 years old like my mother, because I cannot imagine my mother with a cell phone using an app to check the amount of salt that she has in the dishwasher. I cannot imagine that. But and even that all these objects, the first year you are checking the tool, and after that, in most of the cases, you are not checking the tool and you check, okay, there is no salt. I can see that there is no salt here, It's different with a door because you need to open the door. There is no other way but how is the people above 40 reacting to these kind of objects?
That's a good question. The challenge, so usually our customers hand out transponders to their tenants. So these little key fobs on which there is an NFC chip. There's a 2.4 gigahertz chip for communicating with the devices either close by or on proximity. And you can just hold those to the knobs and the handles to have them open. And that works quite well even for older people. So it also has even advantages. You don't have to actually slip a small physical key into a keyhole, which is hard to do for older people because simply of the tremor and the shaking of the hands. It's harder to do, while with a transponder you just roughly push it against the knob and it will react to this. So it can even be easier to handle, actually. It's a bit bigger. It's also older people tend to lose their keys.
I had to make it.
And this is the next thing. So it doesn't really matter. So you just...
Not just older. I tend to lose my keys as well.
Yeah, I think when we cleaned out my grandma's apartment, we found half a dozen of keys hidden in different places. She didn't lose them somewhere else. She just lost them at home. She's hid them somewhere because she didn't want anyone else to find them, and then she didn't find them herself. So for this kind of thing, it's really nice because you just give a new transponder, lock the old one, and you're okay, and you don't need to exchange doors. So even for older people, it can have advantages. But what you definitely need is a second way of opening. So just having
Exactly.
the smartphone as the only way is not okay. You need a transponder. And for us, it really is transponders or nothing.
Because in this case, there is no way to introduce a key. So if the electronic is not working, imagine that I am 75 years old.
It's complicated. It depends on which product you bought. So we have knobs and handles, both of those. The knob sits where the physical lock, the keyhole would usually be. So the keyhole doesn't exist anymore.
Okay.
So you can't use physical keys. So the knob is exclusive, while the handle sits where the handlebar usually is, and the keyhole still is there. So it depends on if you digitalize your handle or essentially the cylinder. And that's a product choice that you have. And this is the crazy thing is like we have a really wide range of different products because we go for the housing industry. So it's not like if you're in a consumer market, if it doesn't work for one consumer, he's going to walk by, but the next one who sees your product might just buy it. If you're aiming for bigger companies in the housing industry, they are going to do a very, very careful check. Does this satisfy all of the requirements that I have? And if not, they're not going to buy anything at all. So once you go into this B2B market, you need to offer a wide range of products to satisfy all of their needs.
Yeah, exactly.
Because there is no, with 20% of the products, I can reach 80% of the customers. It's not going to work that way. A customer where you're only satisfying 80% of what he needs is just not going to buy anything at all. So we have a wide range of different products. You have these little PCBs that you can install behind the bell panel, which we're developing ourselves, actually. You have a knob and a handle. You have a safe where you can put physical keys in. And there's a digital lock to take those out, which is extremely nice for multifamily homes for maintenance reasons. So you have just digitalized one thing. At the cost of one lock, you digitalized kind of all of your rooms that might need maintenance. So there's like something for everyone. And at the end of the day, that's how we can satisfy our customers. And you don't want to know how many variations of each of one of those products we have for outdoors, indoors, left door, right, right and opening doors, for smaller ones because the metal frame doors usually have less space and so on. So there's a lot of variation in the different products that you need to offer. And all of that is what we're doing. That's why the housing industry is, why we're the market leader on the housing industry, because all of these different things.
Yes, because I can imagine that in all these Internet of Things objects, there are objects that are, okay, I can use or I cannot use, imagine. I go back again to this problem with the salt in the washing machine or in the dishwash machine. So I can check physically or I can check in the app. Okay, there is an alarm, but okay, I have to check the application. I don't like the pop-ups in my cell phone. But this case is different because it's something that you need to use daily.
Yeah, it requires a relatively high amount of reliability and robustness.
Yeah.
You can't just say, well, 90% is good enough for me. I'm going to open sometimes.
Exactly.
It's like, yeah, you really need to open pretty much every single time. And then the next thing is that the system overall is really complex. So you have the app with Android, with iOS, all the different Android versions. You have a server involved with multiple services that need to orchestrate and cooperate with each other. You have all the devices, and then you have the gateways in between, and then you have like small stuff like transponders. Even these can break. A transponder can just go wrong after a certain amount of time, and then figure out what exactly doesn't work when, or is the cause for something not working when the customer says, I can't access my door now. It's like there's so many places where that can go wrong theoretically.
Exactly. Because I can imagine when you go out on party with the keys and you throw the keys to the floor and two people step on the keys, nothing happened. But if someone step on the transporter, maybe you can have a problem. Yes.
Yeah.
It's hard for me even imagine like the marvels of ingenuity it takes to engineer such things to work consistently without failure. It must require very thorough testing, almost like rocket science. When you build rocket, you have to predict all the scenarios where something could go wrong, and you just cannot send an engineer on the orbit to fix that. Like you have to first rule out all those possibilities and think how to make it work and make it recover options in case, like there is a network outage somewhere in the city or in the apartment and it failed and you need to still make it work, and more to that, you need to have all those scenarios prepared and thoroughly thought through.
It's a headache. In short, it's a big, big, big headache to manage all of this and make it that reliable. And yeah, it takes a lot of effort. And even the best preparations will not cover everything that might go wrong. So at the end of the day, there's always a certain margin of error that you have. You're buying some of your hardware from third-party manufacturers. You can't check every single piece individually. You do samples, but at some point of time, you trust that certain things work, and you might deliver them and a week later they break down because of manufacturing errors. And there's nothing you could have done about this, nothing reasonably that you could have done about this. But still, it works, and we're doing good. Actually, we're doing good. It's manageable, but it's a lot of effort.
And just out of curiosity, like, did you make some tests to measure and determine how much energy each piece of code takes? For example, you are rewriting a new tenant in the log. You need to, and I assume the device is running some scripts, some logs, and while it's doing this, it consumes amount of energy. Did you make the test like how to simplify the code in order to consume less energy and be more quick, more efficient? Or am I just imagining things?
Yeah, no, that's a good. No. The question is makes sense. Our experience is usually less about every single line of code being optimized or something like this. There's certain things that you need to do, like you optimize wake up intervals. How often do you wake up? If you wake up and listen for someone else trying to communicate to you via radio, if you wake up more frequently, you will respond faster to opening requests, which is good. But if you wake up more frequently, you are consuming more power. So what you do is you try to fine tune the balance between responsiveness and power consumption. And this is the kind of thing that you usually tend to do. You optimize the selection of chips that you're using for power consumption. You try to optimize the amount of storing you do on this, the duration, how long am I awake and listening for radio signals. What those low power devices do is most of the time they're in kind of a deep sleep mode. They barely consume any power. And then sometimes they just wake up, check if there's some outside changes that I need to react to. For example, an NFC being close by, and then they go to sleep again. And then in that case, for example, you can actually, instead of having to wake up regularly, you can make it that it wakes up because the magnetic field changed. That induces kind of the wake up by itself. So now you got rid of those regular wake ups. So this is the kind of optimizations that you tend to do. It's less about the lines of code. It's more about the overall design of the hardware that you're working on and the firmware that runs on it. It's a lot of architectural changes, concept design changes in the thing. And way more rarely is it about specific lines of code being slow, I would say. But yeah, we do try to optimize the algorithms that we're using in our code to not consume too much power.
And what about, so getting back a bit to the DevOps field. So when you write a mobile app, right, there's already, because everyone writes mobile apps, so it's pretty easy not to have physical devices and still be able to test anything. So there are many, many cloud services and many open source frameworks where you have emulators, I always consider like emulators probably, for any model of Android and iPhone. So you can even simulate like gyroscope, any sensor, etc. Simply because there's a big market for this. You have to imagine that in your case, because you build one of the products you're selling is a unique hardware piece. So there is not a software as a service that helps you with testing. The question is, how do you handle it in this scenario where basically there's nothing ready to use?
Essentially, you have to write it, kind of. There's two options that you have, essentially. You don't write a simulator. If you want to test something you need to test with a real device, which means you have every developer needs to have a real device. They already have anyways, and they use that for testing. But there's limits to what you can do. You cannot do load tests. You can't say what happens if I have 1,000, 10,000 devices running on this new version of the system, because you don't start up 1,000 devices for this. You need to simulate them then. That's kind of the option that you have. And yeah, this is something we're working on right now too. So we're adding a simulator for a certain device model that didn't have this before, with the idea that we want to be able to run those simulations, kind of scale up the number of devices, test out if it works, and also integrate it in continuous integration and deployment pipelines. Because in those, what you usually have is like a dynamic environment that you, at least in when you have a Kubernetes cluster, or are more dynamic in the resources that you can allocate. What you like to do is you spin up a new environment, you do your tests on this one, then you spin it down again and throw it away. And these kind of throwaway environments are extremely dynamic. They can pop up any time in any number of those, theoretically at least. And the problem with this is that that doesn't work for physical devices. We don't have devices. We can't just spin up new physical devices. So just like for the load tests, if we want to do this nicely, if we want to do CI/CD nicely, we need to have some kind of simulator that we can run, that will send data, that gets spun up with the environment, sends data, does some testing, and then shuts itself down again.
And now, because you mentioned this, I'm now really want to Google, is it possible to simulate the magnetic field impact on the device? I wonder if it's something that you can do with the software in the pipeline.
Well, what we actually did in the past already, because sometimes the simulated devices are good as like a test driver for the softer side of things, but the simulated devices obviously don't help you test the devices themselves, and we also need to test the devices. So for those, there's nothing that that we can do. We have to test the physical devices actually, and what we did in the past is that we built almost Rube Goldberg-like devices that would bring a transponder closer to a lock and then away again with a rope and a pulley, and then it would just go there, approach it, and it would note down at what distance it actually activated, and then it would pull it away again, and then it approaches again. And we have a video of this, super fun. But this is the kind of stuff that you suddenly see yourself doing, where you thought you're in IT and everything is now virtualized, and we're all going to those cloud environments, and you got rid of all those pesky physical things, and you're in a dreamland for IT engineers because everything is so dynamic and easy. And then no, we are building those kind of things suddenly because we are an IoT and we have physical stuff in our setup, and that is different.
And when it comes to the backend part of this, because you mentioned load test, for example, is there anything, because Amazon, they have a service for anything, right? They have like over 300 services by now. And I think I'm sure they have at least 3 competing with each other IoT services. Do they help somehow with the challenges you face? Or AWS services in general, do they help this IoT part?
I would say KIWI started before the platforms really had IoT services. And so there was already, at no point of time did KIWI say, well, do we throw away everything that we created so far and switch to AWS? And that just never happened as a business decision. If we started from scratch, maybe we would start off AWS. What's it called? IoT Core, I think, for example. But I don't know. We just kind of set on, because we started more than 10 years ago, on our own infrastructure and our own services and systems. Would it be useful? Possibly, but given that I think it was Azure shutting down their IoT offering, kind of hesitant. I'm pretty sure Google, did they already shut it down? Are they going to shut it down?
Google was, as always, famous for shutting down their IoT offering a couple of years ago.
I know barely anyone used it. So I looked into it back then when it was relatively new, and to be honest, I didn't really understand what the benefit of that is. So I just let it be, and I never regretted that decision. And at this point, I think I'm not entirely convinced that's the level on which those happen is the level on which we really need something. It feels like it's an empty shell of do nothing. And at the end of the day, you're still adding all the functionality yourself. And then I don't need that kind of dependency in there. Big dependency with little actual benefits.
I think Google in general, they scared probably many IoT companies with their decision, right? Because that's something, especially like take logs. If AWS one day decides to shut down IoT core, there are like lots of houses with this issue, or you have to have a very complex migration to something else.
Yeah.
So probably it's one of these fields where it's good to be vendor agnostic.
But I have to say that even though those specific services aren't super interesting for us, in general, managed services on AWS are a big help. So managed databases, message brokers, RDS, RabbitMQ, Redis, and so on, all of those systems help tremendously scale up the system or just get it running and keep it running. Because with all the gateways and devices and the operational complexity we have on that side, on the edge and out there in Germany, essentially, it is really nice to be able to scale down the complexity and the know-how that we need to operate the cloud. Because that's why we brought you guys into our company half a year ago, is because we said we need to migrate more to managed services. We're doing way too much stuff ourselves, and that requires know-how where we simply don't have the time to build up the know-how to run these as good as AWS can run them for us on managed services. And at the end of the day, we did that, and it cost less money than before. So it already shows that, actually, we weren't doing it in a very good way, simply for the money purpose. We're wasting money trying to do something ourselves, believing that we're actually saving money currently. Because, well, why do you do something yourself? I think it's cheaper.
Yeah, I think it's a good example where there's like a clear line where there's something that it does not make sense that you completely own, like Postgres databases. It's already a very well solved issue in the cloud providers. So it's AWS has all the like Aurora and all the possible. But then the IoT part, it's something that is really part of your business. That's your core things that you're building, and it makes sense to own it. Is there anything, just for my curiosity, because I'm not really deep into IoT tools and services, what kind of open source tools or stacks exist or protocols that people listening could maybe look into exploring?
Protocols for IoT specifically. I think MQTT is the one that really jumps to mind. We started off back then with a proprietary protocol, and then we switched at least part of our devices to MQTT. Unfortunately, we can't switch all of them because MQTT still is a relatively big dependency that we can't squeeze into all of our devices. So some still stay on the proprietary protocol, but MQTT is in general a quite widely known and used protocol on IoT. And what I can absolutely recommend is stick to something that is more or less standardized, or we have multiple competing implementations. Because, and this is where those IoT platforms come in, from Google, from AWS, from Azure. They are the endpoints that the devices talk to. The devices are out there, usually unreachable for you. The devices talk to your IoT platform. If the IoT platform gets shut down for some reason, your devices are dead. You usually can't easily migrate them somewhere else if it's a proprietary protocol or a very, specific way of using even standard protocols. And it's not always just the protocol. I think even Azure uses MQTT. It's the way they're using it that specifically that's how Azure does it. Now, all of your devices are essentially built for the Azure IoT Hub and nothing else. And if you want to get rid of the Azure IoT Hub, you have to re-implement it. And I think even then you're going to run into trouble with the certificates. or you have to rebuild your devices, compile new firmware for the devices. If you have firmware over-the-air updates, you could be fine, maybe, but it's always a risky situation updating. So at the end of the day, you run into a lot of trouble and a lot of work. And rarely do you have just one kind of device, at least multiple generations of the same device, because you keep developing stuff and keep improving. So after a certain period of time, you have a lot of legacy stuff out there. And that's a huge pain in
And Florian,
the
the question that maybe many people made to you, what do you think that is going to be the future of the Internet of Things? I cannot imagine like a movie, this, sci-fi movies, but what do you think that is going to happen in the next 10, 15 years?
Well, if I had to guess, I would say number one is simply more. There is going to be more Internet of Things devices out there. There's a certain filtering that I'm expecting to happen, is that certain things are just not worth doing in IoT, and some of that is still in a hype cycle, in the hype phase really, and I think some of that will just people will stop doing this. It's not worth it. Quite a lot of the time, there's a lot of big promises of reduced maintenance costs and whatever, and it's not really paying off because people forget how much work it is to keep all of those devices running.
Yep.
So the trade-off is it will show. Time will tell which use cases actually have the benefit that you need and where the trade-off doesn't actually pay off. About technologies, I'm expecting MQTT is going to stay stable, and it will continue to be used quite a bit. I'm expecting that LoRaWAN is going to pick up a bit more steam even. I'm not expecting stuff like blockchains to really pick up a lot of speed. I'm not a big fan of that, and I don't see the benefit in this. Most problems you can solve cheaper in a different way.
Yeah.
So I'm not into that too much. So helium, for example, good example. It doesn't work. I'm sorry, that's not a success in blockchain technology that they were hoping for. I'm not expecting. I could imagine that the narrowband IoT stuff picks up a bit more, but it's really hard to say, to be honest.
Because at the end, the people needs to pay more for something that they can get in some of the cases, not in every case, for much less money. So I have to imagine too that it's related to the economy, no? If the economy go well, I have to imagine that those Internet of Things devices will grow. But if the economy is not so well,
when it's for consumers, usually they're just convenience devices. No consumer needs smart home or whatever. For some businesses, however, it really is about reducing cost.
Okay.
So because you monitor stuff, because exactly when the economy is going down and you don't have the money, then it might be good to have certain things digitized and, in an evil way, say you can let go of certain people who monitored that kind of stuff before because now you've automated it. Hopefully no one gets fired because of that. But then again, it's the nature of automation that jobs disappear and new ones pop up.
Okay.
I've been silent for last 20 minutes because I was basically just mesmerized by your discussion and what you are talking about. It's like that's a future for me, and I was listening with all ears. What's coming and imagining how our life will become in few years from now. But anyway, Florian, I would like to thank you for sharing and for joining today with us. But before we let you go, for those who would love to learn more about Internet of Things, how operating them, what they need to know and what they need to learn before they will jump into this industry, where they can find you to reach you out or to read about the same thing that you do?
Well, obviously, you can go to kiwi.ki
Naturally.
and find about what KIWI does. And then you can find me personally on LinkedIn. again, search for my name or kiwi.ki and you should be able to find me. Yeah, I think that's the best places to start off with. Learning about Internet of Things is like there's not the one resource that I could recommend. It's like a big ecosystem. There's a lot of different things. I'm starting from hardware development, firmware development, network connectivities, the back end operational stuff, DevOps development, the housing industry, digital access, and so on. It's like so many different things coming together in what I'm doing right now, is that there is no the one source that I can point you at.
Yeah. So basically, you have to make a lot of things and know more than just a regular person knows in order to make the future closer.
Buy those things that I have here behind me, books. They help tremendously. That is the one recommendation maybe I can give.
Okay, thank you, Florian. I will post the links in the description to your profile and to kiwi.ki. Anyway, and for those who listens to us, thank you for joining us today. Thank you for being with us. Don't forget to give us your likes and don't forget to subscribe, because there will be another podcast episode in 2 weeks. Don't miss that. And if you want to learn more about what happens at MKDev, about our articles and videos, don't forget to subscribe to our MKDev Dispatch bi-weekly newsletter. We post all things there. And we will see you and hear you in 2 weeks in the next episode of DevOps Accent. It was Pablo, Kirill, me, Leo, and our guest, Florian. Thank you and see ya.
See you.
See you.
Thanks, everyone.
There are no challenges that we couldn't overcome. Whether it is immediate infrastructure problems or planning a future project, we won't simply answer your questions. We become a part of your team to help you complete the mission. Our solutions consider the interests of your business and the combined expertise of the industry, as our staff is made up of more than a dozen experts in different areas who share decades of field-tested experience and knowledge with you.